Okay, so I'm going to look at question 2 now, and just let's read it first. So it says it's given that theta is the acute angle such that sine theta equals 12 over 13. Now we want to find the values of cot theta and cos of 2 theta. Okay, so firstly, we could, take this equation, sine theta equals 12 over 13, take arc sine of 12 over 13 to give us theta, or sine inverse of 12 over 13, and that will give us theta. However, when we do that, we can say that, so let's say theta equals, sine theta equals 12 over 13. Well, that means that theta equals sine inverse or arc sine of 12 over 13. And that gives us 1.176 radians. And this is about 67 degrees, which is an acute angle, so that satisfies the question. However, we've had to round this, and in the question it actually wants an exact value, so this method, this process is completely useless in the context of this question, because we'll have to round and we'll get values for cot theta and cos 2 theta that are not exact. Okay, so we're going to have to think about a different way to do it, and I must admit that when I was doing this the first time, I went about it this route, find the exact value after I completed the question, and had to redo it. So let's start with finding theta, which is going to be where the magic happens, as it were. Okay, so let's think about our definitions for sine theta. What is sine theta? Well, if we remember SOHCAHTOA, then let's write SOHCAHTOA. Well, then sine theta, that's just opposite over hypotenuse. So an opposite and hypotenuse obviously being for a right angled triangle. So opposite side in this case is of length 12 and the hypotenuse is of length 13, so we can draw a nice diagram. Okay, great. How should we do this? Yeah, let's leave it like this. So let's say that's our angle theta. Okay, then our opposite side is going to be 12. Our hypotenuse is 13. And using the beauty of Pythagoras, we can say that our missing side is going to be of length 5. Okay, that's just a Pythagorean trick. 5 squared plus 12 squared equals 13 squared. Fantastic. Now we can go about solving the question. So part I. We know that cot theta equals 1 over tan theta. And what's tan theta? Well, tan theta is just opposite over adjacent, so that is 12 over 5, so that's 1 over 12 over 5, is that right? Yeah, 1 over 12 over 5, which equals 5 over 12. And that's our first answer. Second, part 2. Okay, cos of 2 theta. So thinking about this question, we don't actually have any information about 2 theta. We've only got information about theta, but we can change cos 2 theta using the double angle formula. So we can change this to, I think it is cos squared theta minus sine squared theta. Okay? So we know cos theta. Cos theta is adjacent over hypotenuse, so that's 5 over 13 squared minus sine squared theta. And sine theta is 12 over 13, so that's minus 12 over 13 squared. Okay, and if we plug that into our calculator, 13 squared, that's 21 over 169, 25, sorry, 25 over 169. We don't need a calculator really, minus 144 over 169, which equals minus 119 over 169. Okay. Fantastic. That is the second answer. Great. If you have a really good calculator, you probably could have used the first method, changed from decimal points to fractions, and you probably would have got the same exact answers. But this is the way to do it with the correct working.